Hi everyone. We'll be starting the presentation in about 6 minutes 50 seconds. So when this timer ends, we will start the presentation on time. Thank you, all of you who are earlier. Let me know if you hear me. That will be helpful. And if you have any problems with reception, that would be also nice to know. Maybe I can do something about it. I think from my side, everything works. So let me know if everything works for you. Okay, loud and clear. Audio is good. Great. Thank you, Oliver. Okay. I've seen that you checked if comments are working. That's great because you will be able to use comments to ask me questions. If you ask questions during the presentation, I will try to answer them. If the answer will be short, I will be able to answer them in the meantime. But for longer answers or more complicated questions, please wait until the end of the presentation. And then I will try to answer all of your questions. All right. Sounds good. Great. Audio okay. Nice. All right. So tell me, how many of you already know me? And how many of you who already knows me? And do you remember when we met for the first time on the internet? There is a delay, a couple of seconds, so if you tell me something, I will hear that in a while. Oh, cool. Somebody posted this link at our retro Discord server. Nice. Took a class. Oh, great. First time. Still haven't forgotten. Great. All right. I see some of you get excited about raster lines. That's great. And there will be plenty of them during this presentation. Okay. All right. Oliver discovered my 64 bytes videos. I'll talk about those videos later after the main presentation. So don't worry. If you don't know me, my name is Michał Taszycki, and I keep old computers alive. And I do that for a living. I will tell you a bit more about that in a minute. Great. If you hear the echo, yeah, that might be my room or maybe something with your speakers. Great. It seems that nobody else had any problems. So tell me, do you have real Commodore 64? Yeah, other people tell me that there is no echo, so that might be a problem at your side. Great. So, who owns a Commodore 64, the real one? The 40-year-old machine that should be dead, but it's not. Nice, 3 of them. Okay. Nice. Since 1998. Great. All right. So one of the important things about Commodore 64, you don't need to own the computer to program it. You just need an emulator Emulators for Commodore 64 are really great, and most programming that is done nowadays is being done on emulators. So don't worry if you don't own it. Nothing is lost. You can get it someday, but for now you can use an emulator. There's nothing shameful about it. Emulators are really good. Okay. Okay. I have a PAL C64 and Ultimate 64. So for those who don't know, Ultimate 64 is a version of Commodore 64 that is hardware, that is emulated in hardware. It works mostly like Commodore 64, but has additional features. You can also have the Ultimate cartridge, attach it to a real Commodore 64, and most of these features will be also available. Great. Robin, if camera seems to be unfocused, that's okay, because I'm not the important one on the screen. The important thing will be on slides. And I see that it is time to start the presentation. So let me remove the screen and turn off the timer, share slides, and we'll start in just a second. Wait for it. All right. Okay, so thank you all for being on time or being earlier. We won't wait for people who are late. There will be a recording available. In the description for the video, you can see a link to a registration page. It's 64bytes.com/raster-live. I maybe type it in the comments. So it's 64bytes.com/raster-live. If you go to this link, you can register. And if you register, you will receive not only the recording, but also slides and the source code for this presentation. Because there will be a lot of code in this presentation, but don't worry. And you don't need to know anything about assembly. I will be explaining what I need to explain, but I'll try to focus on the high-level stuff, so that you know what I mean by raster shaders. You know how to code some effects on Commodore 64. And then if you're interested, you can, after the presentation, watch a replay, watch slides on your own pace, and dig into the code, and then you can understand everything in detail. So you don't need to do screenshots. You don't need to write anything down. You just need to relax and have a great time. All right. So let's start. I'm going to show you what are raster shaders on Commodore 64. So first, who am I? I know already that some of you know me for a couple of years. I keep old computers alive. My name is Michał Taszycki. You can find me on social media as Michał T, written like you see on the screen. And I can teach you to program Commodore 64 one byte at a time. if you go to the website 64bytes.com, you will see my video tutorials on programming Commodore 64. After the presentation, I will tell you a bit more about them. And if you are interested in learning how to program Commodore 64, I invite you to stay for that part. And if you want a small gift from me, the first season, which is the first 9 lessons for free, wait till the very end of the presentation, and I will give you a discount code that will be enabled tomorrow or a couple of minutes after the presentation, because I'm on a different computer and need to do it. I need to do it from my other computer, but I will give you a discount code that will give you the first 9 lessons for free. But only if you stay for the end of the presentation. Great. Paul is struggling to get sound because of Bluetooth headset. Paul, don't worry. You can watch the replay later again. Right now, focus on slides and you will understand pretty much everything. Okay, I have a bad news for you. Commodore 64 belongs to the past. It's a 40 years old computer and nobody uses it anymore. And right now we have modern computers with modern graphic cards. Back then we had old computers with old graphic chips. So you see the Commodore 64 on the screen and you see the graphic accelerator for the Commodore 64, the VIC-2. This is the chip that generates graphics for Commodore 64 in a similar way that modern computers have graphic cards that generate graphics on the screen. So the idea of graphic card is that this is the hardware that is optimized to display stuff that is needed in modern games, so that the CPU can do other things. And that was the same idea with the VIC-2. It's also the hardware, specialized hardware, that is optimized for generating graphics in games that were being done at that time, so that the CPU can do other stuff. So today, the graphic cards can generate this image. For example, we have beautiful 3D games that can be run on graphic cards. But back then, we had beautiful 2D games that also had great graphics for that time. Instead of rendering millions of triangles and shading them with different colors and different lights, we had 8 bitmaps that we could move anywhere on the screen. And it was a big deal because like copying bits on a screen with a CPU that has 1 megahertz frequency, which is like 1,000 times slower than the first iPhone, was pretty challenging. So Commodore 64 had this graphical chip that could display 8 bitmaps on the screen, and we could have a graphics like that. But wait, back then we also had 3D graphics. What's up with that? In Total Eclipse, you could move around with in a completely three-dimensional world, look up and down, which was not possible on Doom on a PC, and move around the 3D world, build out of polygons, and have an amazing game. There was one caveat though. You couldn't talk about frames per second in that game. You could rather talk about seconds per frame. It was quite slow, but it was possible to display a real 3D world on Commodore 64. But wait, back then, no. Right now, we have plenty of beautiful games that are created for Commodore 64. every year we get around 70 new games, 70 really good new games that are released on Commodore 64. Plenty of demos, plenty of music, plenty of graphics. And when it comes to games, there is one interesting thing about them. So the Commodore 64 didn't change. It is the same computer it was 40 years ago, but every year new games show up for it, and every year they are more beautiful, they are faster, and they use effects that were not possible before. And this is interesting because we have every year we have faster computers, but applications that are running on those computers are getting slower. So what's up with that? How it's even possible? Well, in modern computers, we have something like pixel shaders. Modern graphic cards, when they generate image on the screen, they generate pixels. And for each pixel on the screen, they can run a simple program. And this simple program is called a pixel shader. And the classical use for pixel shader is to calculate the lighting, to shade an object, hence the name. So in this particular case, we get some input, some vectors, and we calculate how much of light we calculate the amount of light that each pixel gets that is displayed on the screen. And if we take this image on Commodore 64, this is the effect called Raster Bars. Basically, we draw a line of a different color for every raster line on the screen. So the important thing about Commodore 64, it was displaying the image on cathode ray tubes, and it was displaying image line by line. And the graphical chip knew exactly which line is being rendered at this particular time on the screen. And the graphical chip could tell the CPU, hey, I'm at this line, please stop doing what you are doing and execute this code. So in fact, the graphical chip could run a program for every raster line on the screen, in the same way as modern graphic cards could run a program for every pixel on the screen. So this way, as we have pixel shaders on graphic cards today, we had raster shaders on VIC-2. But enough of theory. I want to show you some code. Please don't be afraid. I don't expect you to know the assembly. I will show you how to code those things from scratch. Don't focus on them too much. I will be focusing on the high-level concept. You will get the source code after the presentation, so you can dig deep into the source code. Right now, relax. Try to understand the high-level concept. Get the small epiphany when you learn how to open the border, for example, how to display raster bars, and so on. And if you have any questions during the presentation, feel free to ask them in the comments. I'll try to answer the short ones. Longer ones will wait until the end. And another thing, if you like the presentation at any moment, feel free to let me know, because in real presentation, in real life, I would see you as an audience. I would see if the presentation is great or not. And here I can only communicate with you with comments. So if you want to tell me something nice, please tell me with a comment. And you can also, if you find something interesting, feel free to make a screenshot and post it to social media and tag me. I will retweet it or put it on Instagram, And this way, more people will know how awesome Commodore 64 can be. All right, that's it. So this is the comparison of shaders on modern hardware and the shaders on Commodore 64. Of course, nobody called those small programs executed by VIC-2 raster shaders. This is something I noticed because I have a background in computer games. The similarity, we'll talk about them, what raster shaders are, in a second. All right, let's code in assembly. Don't worry, it won't hurt. This is the minimal program that you can do in modern assembly. By modern assembly, I mean a program that you write on your PC or Mac or Linux in a text editor. Any text editor will do. I use Sublime or VS Code. Then you compile the file with, for example, Kick Assembler. I use Kick Assembler because I like the features of that program, but you could also use Acme or TASM or some other cross-platform assembler. And then when you compile the code, you generate a PRG file, and you can put this PRG file onto a disk. You can put it onto the real Commodore 64 or execute it in an emulator. So this is the minimal program. The first part, the basic upstart macro, tells the assembler to generate a small basic program that will execute the assembly program. And this is the program. Main is a label, which is just a named place in the memory that we can jump into. And RTS is an instruction called return to subroutine. If we execute it in the main program, it will exit. And this is exactly what this program do. If we run it on an emulator, it will look like this. First, we load it from somewhere. Then we run the basic program. And the basic program executes a sys command, which jumps into assembly and execute our program. And our program executes RTS instruction and exits immediately. So this is the equivalent of hello world in assembly. The most important instructions on Commodore 64 are LDA and STA. LDA takes the value from the memory and puts it into the A register, so-called accumulator. STA does the opposite thing, takes the value from the register, the A register, the accumulator, and puts it into the RAM. We do this because the CPU of Commodore 64 cannot operate directly on the memory. At least it cannot add things in the memory. It cannot subtract things in the memory. First, it needs to take the value into the register, which is just a 1-byte memory in the chip itself. And then we can do something with the value in the accumulator and then write it into the memory. Why those two instructions are the most important? Because most of subsystems on Commodore 64 are mapped onto the memory. The interface for the graphical chip are the registers of that chip. And those registers are mapped onto specific places in the memory. And when we write to those places or when we read from those places, magic things happen. So we communicate with a graphical chip, we communicate with the SID chip, and we can play music or display graphics just by writing things into the memory. So those two instructions are the most important ones, because without them, you cannot do anything on Commodore 64. LDA has two versions. The first one allows us to take the value from any part of the memory. We just put the address, and the value from that address will be put into the accumulator. The one with the hash or pound sign will take the value from the memory, but right after the instruction. And then STA has just one important variant that is right into the address. There are some other variants, but they are not important for this presentation. All right, so how do we change the background color on Commodore 64? Well, first we need to know those magic addresses in the memory. For the VIC chip, the border color stays at the address D0 to 0 in hexadecimal numbers, and the background color is at D0 to 1. In order to not remember those magic numbers, we can assign them to labels or to constants, and then use those labels or constants in our code. And this is what we do here. First, we take the value of the dark gray color, which is a predefined constant in kick assembler, and then we put it into accumulator, and from accumulator we write it into the memory where the background color register stays. And we do the same thing for the gray color, and we put it to the border color register. To make the programming a bit easier, we can put the code into the macros. Macros are features of modern assemblers which work like copying and pasting. First, we define the macro. Macro has to have a name. It can have some arguments. And then we put some code into the macro that can be dependent of those arguments. And then if we call the macro, the code from here will be copied here. So it works like copy and paste. It's not exactly like functions or routines, because in functions and routines, the code stays in the memory and we just call it and then go back from it. Macros just copy and paste the code into the memory. So if we extract the macro like that, we can change the background color or the border color in a bit more readable way. All right, if we execute this program, it will look basically like that. There is a question, how many params can you put into the macro definition? I don't know, probably a lot, but it's not a good programming practice to put a lot of parameters in the functions and macros. So yeah, don't overdo it, but you can probably put a lot of them in a macro in kick assembler. Oh, and this is the real hello world in assembly for Commodore 64. I agree, because it's harder to output text on Commodore 64 than to change the border color. So this is basically the first program in assembly that you will do. All right, meet Raster Bars. Do you want to know the secret behind this effect? Let me know, and I'll drink some water in the meantime. Tommy asks if this is the kick assembler. Yes, I use the kick assembler for my assembly because I like the syntax, I like the metaprogramming features. Okay, you want to know the secret behind Raster Bars? Absolutely, Sarkams, no. Just here for fun to distract me from work. All right, you're ready for that? Okay. The secret behind Raster Bars is doing nothing. I'm serious. That's what I mean. We change the background color to some color, let's say black. And then we do nothing for some time, and then we change to some other color. And that's it. How do we do nothing on Commodore 64? We use the NOP instruction. This instruction takes 2 cycles and does nothing. If we need more delay, we just add additional instructions, and we can add many more NOPs. If we need like 230 of them, we can copy and paste them, or we can use the meta-programming feature of the kick assembler, which allows us to use the scripting language during the compilation time. So before the code is generated on Commodore 64, we can program what is being generated. So in this case, we tell the kick assembler to do this thing 230 times. And that's it. It will copy and paste NOP into the executable 230 times. And to make the code cleaner, because we will be using a lot of delays, we can create a macro called nops, add a count to it, and put this for loop into the macro. And whenever we put the macro, it will copy and paste this many nops in there. Okay, so this code will draw the bar somewhere. And there is the other part that we need to know. We need to start drawing at the specific raster line. And this is where the raster shaders comes in. We need to invoke a raster shader. So we need to tell the VIC2 chip, tell the CPU to execute some part of the program at a specific line. But before we get there, we need to know how it's being done. Take a look at the cursor. Do you see something weird? Well, I'll tell you what's weird about that. It's blinking. And if I type something on in here, it will still blink. How it's possible? Because it's reading something from keyboard and it's blinking at the same time. Well, this blinking is generated by an interrupt. There are timers on Commodore 64. There are chips that can generate timer ticks multiple times per second. And those chips can generate interrupts based on those timers. So by default, there is an interrupt enabled on this one timer, and there is a routine connected to this interrupt that makes the cursor blinking. So let's first start with putting our program and attaching it to this default interrupt and see what happens. So interrupts are small routines, and I call them shaders for the purpose of this presentation, that are invoked by some kind of a signal. It can be a timer generated by those special chips, or it can be generated by getting to a specific line on the VIC chip. Okay, so here's our shader. We attach a label, Raster Bars IRQ. So we change the border color to black, we wait for some time, and we change the border color to dark gray. And then we jump to IRQ handler routine, which is the default routine. Now we need to attach this program to a signal. So we need to tell the CPU when the interrupt gets called, this program should be executed instead of the default IRQ handler. So first we use the say command to disable the IRQ handling, because we don't want to interrupt to happen while we are switching the addresses in the memory, because then we will jump into random address in the memory and crash the computer. So we disable interrupt handling, then we inject our Raster Bars IRQ handler. So this is our routine, and we need to put the address into a specific place in the memory. The address on Commodore 64 takes 2 bytes, so we need to take the least, how do you call them? Least significant byte first into the one place in the memory, and then we need to take the most significant byte to the place in the memory right next to it. And if those 2 bytes will be at this address, the interrupt routine will jump to that address, and then our routine will be called when the interrupt is signaled. Okay, once we're ready with the switching the address, then we can enable the interrupt handling, and from now on, when the interrupt happens, our program will run, and it will look something like that. This is our raster bar, but it's quite erratic. And why is that? This is because the timer is not exactly synchronized with the refresh rate of the screen. We could do that. We could synchronize it manually, but instead of using timer to generate the interrupt, we will tell the graphical chip to generate the interrupt itself. So instead of using the timers, we'll use raster interrupts. So first we delete the injection of address of our routine to the interrupt handler address. Then we disable the interrupt generated by timers. So we need some magic value. We need a magic value. We need to put it in some magic address, which is mapped into the interrupt control register for the first chip, the second chip, and then we need to make sure that any already scheduled interrupts is not running. And we do that by, we need, not like that. We need to read from a place in the memory, and if we touch this place in the memory, the chip will know to not execute the interrupt that is currently scheduled. Okay, you don't need to understand it right now. I probably don't remember it exactly how it works right now. If I need to remember it, I watch my own lesson and I remember it. I remind myself. For now, you need to know that you need to execute this part of the code to disable timer interrupts. And then you need to enable raster interrupts. So we need another magical place in the memory. We need another magical value. So we enable this bit in this register, and this will enable raster interrupts. And then we will use a macro that we'll define in a second to request the interrupt at this specific line and with this specific address. So we will tell the interrupt handler to jump to this address and handle our raster shader when this line is reached. And once all of that is ready, we can enable interrupts, and from now on, we will have a raster interrupt enabled. So how to choose this raster line? At the end of this macro, we will do the same thing as we did before. So we'll take the address of the handler and we will put it into the specific place in the memory where the interrupt handlers should be. So when everything is ready, the interrupt handler will jump into this address. But then we need to pass the line number to the register of the VIC2 chip that does two things. It either we can read from it, and if we read from this part of the memory, we will get current raster line. And if we write to that register, we will define the raster line that will trigger the interrupt handler. There is a small problem because there is more than 255 raster lines and they won't fit in 1 byte. So if the line number is greater than that, we will need to put 1 more bit into another register. And if the number is less than 255, we will need to clear that bit. And to do that, I defined helper macros to set those bits and to clear those bits. So we put the address, we put the value into the accumulator. We take the address into we take the value from the memory at the address into the accumulator. We execute the OR operation with this value and the accumulator, and we store the updated value into the same address. And to clear that, we do the same thing, but we end it with a negated bit mask, and that's it. You could do this in some other way. You don't need to define those macros, but I prefer to specify those macros because they are more readable for me. And that's it. Another magical code that it's needed to request specific raster IRQ. This is what you need to understand in a higher level. And once you do, then we can use this code to create new exciting stuff. Okay. One last thing is that raster IRQs need to be acknowledged, which means that we need to store this specific value into this specific register of the VIC2 chip. If we don't do that, the VIC2 chip will generate the interrupt constantly, and our program will hang, basically. So we need to tell them, hey, we handled the interrupt, you can stop doing it. And that's it. So we can put it into a macro, which will do the magical stuff and exit the interrupt handler. All right, so when we execute this program, we can see that our raster bar is much more stable. It stays at this specific line. Then we added delay, and it ended here. There is one caveat though. It's not stable enough. It blinks and it starts in the middle of the line. What can we do? We can stabilize the interrupt, but it's complicated. It takes 2 5-minute lessons to understand how it's being done, but it's too complicated for this presentation, so we will fake it. What we can do is to hide this blinking under the border. So we add some knobs at the beginning, and our raster shader will still be jittering, so moving back and forth, but it will do that under the border, so it will look like it's stable, and we can go from there. Stephen says that macros too advanced. Feel free to ignore too advanced macros and focus only on the high-level stuff. You will be able to get into the code after the presentation when I will send you the code tomorrow. Thanks. All right. I was hoping to learn how to stabilize raster bars. The high-level concept is to first minimize it and then use a specific trick to get rid of the one last cycle. So this is the two-step process. First, you minimize the jittering from 7 cycles to 1, and then using a specific instruction that can take 3 or 4 cycles. You need to execute it at a specific cycle, and then you stabilize the raster routine, and that's it. And I will tell you more about that after the presentation. For now, we need to fake it. Okay, let's make more bars, because we can do one. Let's make more. How we do that? Basically, we do nothing. We change the background. We do nothing. We change the background, and we need to play around with those values until they look good. Basically, that's how you do it. You could calculate cycles, how many cycles you need, but you can also run the program a couple of times, tweak those values, and you will create raster bars. And if we do it a couple of more times using specific colors, then we can generate a raster bar like that. If you use different colors, you will get a different effects, but basically this is the way to do that. Why those numbers are different? This is complicated because not every raster line is equal on Commodore 64. on some raster lines, we have more cycles to use. On some raster lines, the graphical chip needs to do a bit more work, so it steals our cycles. So sometimes we need to wait less, and sometimes we need to wait more. And those values you can tweak when you run the program a couple of times. And that's it. Okay, we know the raster bars. I hope you liked it. This Oliver says because of bad lines. Yes, those lines where the graphical chip steals our cycles are called bad lines, but it's a bit more complicated for this talk. All right, meet sprites. So modern graphical cards can generate millions of polygons and 3D objects. Graphical chip for Commodore 64 could generate 8 hardware-accelerated bitmaps called sprites. So to enable them, we need to set 1 for each specific bit in one register, and we enable all 8 sprites. Then for every of those sprites, we will set the horizontal sprite position. I did that with a macro. I did that 8 times. And basically, I take the index of the sprite and then generate specific position, horizontal position on the screen. And we will define the vertical positions within the interrupt. So this code can be executed just once in our main program, and the rest of it will be generated in interrupt. The sprite position is set by loading some stuff into accumulator and storing some stuff into magical place in the memory, which defines the register responsible for the position. And in this case, the horizontal position also can be greater than 255. So I use the same helper macros to set a specific bit in another register to specify if the position is greater than 255 or not. And that's it. We already have a shader that generates raster bars. Now we need to display sprites, and we will do that in another shader, so in another interrupt. So first we will do additional interrupt handling routine. We will call it sprite row IRQ1, and we will do something here, and then we will exit interrupt handler. So we will do exactly the same thing as we did with raster bars. But what we need to do is at the end of this interrupt, we need to schedule this interrupt. And at the end of this interrupt, we need to schedule this interrupt. So basically, we get to this line, we execute some part of the program, and we schedule another program at another line. And so basically, what we need to do is create a chain of interrupt handlers that will be so each link in that chain will schedule another program. So this one schedules this one schedules this one, and that's it. And what we do here, we just set the vertical position, we set the color, and we set bitmaps. And I won't bore you with the implementation of the macro because it's also LDA, STA, LDA, STA into some specific magical places in the memory, and it's boring. So basically, focus on setting the vertical position, setting bitmaps, and setting colors. And this is how it looks. We execute this macro somewhere here. Then we enable those sprites, and then we execute another interrupt handler somewhere here, and then we change border colors here. So by the way, do you know what is raster time? Let me know, and I sip more water. Okay. If you know, that's great. If you don't know, raster time equals party time. Yes. Yes, the time it takes a routine to run in terms of raster and beam distance. Exactly. But it's also a simple way to measure the complexity of a routine. So the definition is more complex than the implementation because we just change the border color at the beginning of our code and we change the border color at the end of our code, and we see how much time have passed in the length of the border color change. And we do that here, and we will see exactly how many raster lines elapsed during the execution of the code. This is important. We need to watch out because if we add some code before those knobs, we will need to tweak this number because changing border color takes a couple of cycles, and we need to subtract those cycles from here. And if we do that, we see the raster time required for displaying sprites and the raster time required for raster bars. So this one is obvious because we do stuff on each raster line. So it will always take as many raster lines as you see on the screen. But if you do some stuff that is not visible or not doing things on every raster line, it's useful to know how much time the code takes. So this is one way to debug code on Commodore 64. So as we see, this part of the code takes less time than this part of the code. Okay, let's display more sprites. But wait, what? Yeah, I told you that Commodore 64 can display up to 8 sprites, and I lied. Commodore 64 can display 8 sprites on one raster line on the screen. Yes, that's inconceivable, but it's true. Basically, we need to wait for another specific raster line. Once we draw 8 sprites on the screen, we wait until they are fully drawn, and then we can execute another interrupt and display them again. So when we have our interrupt chain, which has 2 links right now, so sprite row IRQ calls the raster bars IRQ and the other way around, we need to put additional interrupt into the chain. So we will create another sprite row. And instead of calling this interrupt from here, we will call this interrupt. So we will jump to another line, and then we will go back to the first interrupt. And that's how you do any number of raster interrupts on Commodore 64. So if we execute this program, we will have one raster shader that will display 8 sprites. Then we will display a couple of raster bars, and then we will display another 8 sprites. And what is important is that we can change parameters of those sprites. So we can change the position, we can change bitmaps that will be displayed on those sprites, and we can change their colors. So it's not like if we set sprites here, they will be displayed exactly the same here. We can change pretty much everything regarding we can change pretty much every aspect of that sprite and display it again. So those are slots for bitmaps that we can swap around. All right. Now let's do something more interesting. Tony says it's multiplexing. It's like black magic. It's not exactly multiplexing. Multiplexing it's much harder because general multiplexing on the Commodore 64 allows movable sprites to be displayed on the screen. This method only allows static sprites because in real multiplexer, first you would need to sort those sprites and then execute dynamically different raster interrupts at dynamic lines and do it in a quite clever way. So multiplexers, general multiplexers, are much harder. This is the easiest way to achieve more than 8 sprites on Commodore 64. All right, and that's clever. I didn't come up with this. More smart people than me figured it out a long time ago. But like, there is a plenty of things that haven't been yet discovered on Commodore 64 and will be discovered in following years, so don't worry. There will be more clever stuff on the way. Okay, let's do something else. Let's open the border. So if you see the screen on Commodore 64, we have this border around. And if you place the sprite on the border, it will hide beneath it. And you cannot draw any other characters under the border, so it's pretty much useless. But if we could open the border and display sprites there, we could get more screen real estate. Let's add additional interrupt and display a thin green line at the line 248. So if you look at the screen, this is the line, and it's important that it's here because when we change a specific VIC to register, we can make the border wider, or we can make the border thinner. And why would we do the border wider and hide more of the screen? Well, basically because the Commodore 64 have a feature which can scroll the screen. And if you scroll the screen, the area that is below the border gets visible for a bit. So to hide that fact, we can make the border wider, and then if we move the screen with the VIC chip, nothing weird will be displayed on the screen. But our screen real estate gets smaller. And this feature can be abused on Commodore 64 because drawing the border on the VIC chip works like this. When it generates the image line by line, it doesn't check for drawing the border on every line. It only checks in two places, here and here. So if we execute, if we make the border wider and the VIC chip gets here, it will see that it doesn't need to draw the border. And so it won't start drawing the border. And then we execute the interrupt at the green line and make the border wider, and the VIC chip goes here and see that the border is already wider, so it doesn't need to start drawing the border because it thinks that it already started drawing it. And that's it. And this, well, this is like we are telling a lie to the VIC chip that, hey, dude, don't start drawing the border because you already did. And we need to do that on every frame. So on every frame, we need, before we get to this interrupt, we need to make the border thinner. And then when we get to the interrupt, we need to get the border wider, and the VIC chip will stop drawing the border altogether. And that's it. So before reaching that line, we will enable this thin border mode, which is normal mode for Commodore 64. And after we pass that line, so in this interrupt, we will enable this wide border mode. And once we do that, the Commodore 64, the VIC chip, stops drawing the border. And that's it. So the problem is that we cannot put any characters in that part of the screen. So what can we do? Well, what's the point of opening the border if we can't put any graphics? Well, we can put some graphics on the screen. We can put a barcode. There is one weird place in the memory that is mapped into register in the VIC chip, and when we put some value into this byte will be copied into this space under the border. So if we put this pattern, it will create a barcode or something like that. So this is one thing that we can put under the border, and the other thing is that you can move sprites there, and sprites will be visible in this place. So we just need to execute additional raster shader. We know already how to do that, and we can add additional sprites on the screen. One other thing that we can do with raster shaders is we can use them for different things than to generate graphics. You know, like modern graphical cards can be used to mine cryptos, to break passwords, and to do some weird stuff. A VIC chip can also be abused to play music. Why? Well, we need to know what is a SID file. The SID file is kind of like an MP3 for Commodore 64. So if you have a SID file, you have a music in this file, and you could play it on Commodore 64. But the difference between MP3 and the SID file is that the player is included in the SID file. So every SID file has an executable program that can play the music. And usually, you need to run those programs in a raster interrupt. So how you do that in QuickAssembler? First, you need to import the binary from a file. Usually, we need to import it at the address 1000, sometimes at the other address, but usually it's 1000. So we specify the space in the memory. Then we import all the bytes from the binary file that contains the player and the music. And then we need to initialize the player, which usually means we jump to this address. And then we specify raster interrupt, and we play a tiny bit of music. It works like that. Raster interrupts are executed 60 times per second on NTSC Commodore 64 and 50 times per second on PAL Commodore 64. And usually SID files are created for a specific machine, and they will sound different on the other machine. And you could work around that, but if you execute them in the raster interrupts, they will sound different. So how do you do that? You jump into a subroutine that is defined in this place in the memory, and you have different subroutines for different songs in that file. Or maybe not. I might be remembering wrong, or you change some value in the memory and then jump to the same subroutine. I don't remember. You can definitely check it in the documentation. But basically, what you need to do to play the music is to initialize the player once in the main program, and then in each raster bar, that in each raster interrupt, you need to play a bit of music by executing a subroutine of a player. So the player just reads part of the music and then sets registers for the SID chip, and the SID chip will will play the music for us. We'll play just a couple of notes of the music, and on the another frame, it will play a couple of more notes of the music, and it will work. So, as you can see, the player takes a bit more raster time, and the time changes because music can take more or less computational power. And basically, if we clean up the raster time, we can see a couple of interesting effects on the screen, and we can hear beautiful music that has been played from within the Raster Shader. And that's basically it for the presentation. And tell me, how did you like it? And if you learned something from it. Yeah, it's cool putting score sprites in the top bottom borders. Yes, so you can use those raster shaders in your game, and you just put score. You render score with sprites, and then you can use. You don't need to draw score with characters or use the screen real estate on the screen, and you can use a border to do that. Yes, that's true. Commodore 64 only allows for 8 sprites, and you can change the position, look, and color of all those sprites, and that's true. Yes, that's true. Okay. Can you combine those sprites to make larger sprites? Yes, if you put them side by sides, you can create those sprites. And if you put one sprite on top of the other, you can combine it with different graphical modes, and you can increase the resolution and increase the number of colors. All right. So tell me, if you liked it, do you want more? Nice. Love the music. Unfortunately, I didn't write it. I have no idea. I have an idea how to write the music, but I can't compose the music. So I took it from the database of SID files. I should do it more often. I'll try to do it more often. Okay. So, you ready for more? So when it comes to the presentation, you will get slides, you will get the replay, and you will get the source code tomorrow. If you registered for the event, I will send them to you in a separate email. If you watch this presentation as a replay, you are on the web page that all of this thing is included. Okay. So for those interested in programming Commodore 64, I have something I have something interesting for you. So I told you that I can teach you to program Commodore 64 1 byte at a time. So as you can see after this presentation, one thing I do is to compress the knowledge to smaller stuff. I try to teach you something in the smallest possible time possible, to respect your time and to give you a small epiphany to tell you something more. If you want to get deeper, of course you need to get deeper into the code to understand it, to code it yourself. But to get a gist of the idea, you can just do it much faster. And I created 64 bytes, which is short and sweet Commodore 64 programming lessons. And those lessons contain tons of small epiphanies. So each lesson gives you something. Each lesson focuses on one small thing, and the first aim of mine was to create those lessons so after watching just 5 minutes you get the small epiphany, like, oh, so that's how you open the border. Oh, so that's how you play SID music, or so that's how you use extended background color mode, which is pretty interesting color mode on Commodore 64. Or that's how you change the custom character set. So you don't need to want to program this thing. You just need to be curious to get something out of my lessons, because those lessons are short, focused, and deep. They are short because they respect your time. Each lesson is like 5 or 10 minutes long, and each one is focused on one small thing. When I teach high-res bitmap mode, I don't teach sprites in the same lesson, unless they are needed for some specific reason. And each lesson is deep, because I read old books, so you don't have to. So I spend a lot of time on reading old books, reading old magazines, going through forums, typing the code, checking some corner cases, and then I try to compress this knowledge into one small but deep lesson. So in each lesson, I try to put something that even advanced programmers will find interesting. So for example, when we talk about sprite character priorities, which is which sprite is displayed on top of each other, and which sprite is displayed on top or behind characters on the screen, and how graphical modes affect that. So all of that is covered in a short lesson. So even if you're an advanced programmer, you can just watch the lesson in 10 minutes and remind yourself how it's being done and why it works like that. But it's obviously not only for advanced programmers. The series starts from scratch. We start with basic and we jump directly into assembly in a couple of steps. And there are difficult concepts explained. Somebody asked about raster stabilization, so I explained that in 3 lessons. One lesson focuses on changing the 5 to 7 cycle jittering to just 1. The other lesson focuses on removing that one last jittering. So it's a 2-step process, 2 5 to 7 minute lessons, and you know how to stabilize the raster routine. You watch another lesson and you know how to optimize it. And it's step by step. So those lessons are ordered so that I don't introduce advanced technique if I didn't talk about techniques that are needed to implement that. For example, I first teach you how to open borders, the top and bottom ones. Once you know the concept, and once you know how to stabilize the raster, you are ready to open the left and right borders, which are much harder because you need to do that on every raster line, open the border, and you need to do that at a specific cycle. This is what makes it harder. So it takes a couple of lessons to get there, but after 4 or 5 lessons, you can open the border on any part of the screen, and you can display sprites there. I'm a programmer for about 16 years. I started programming because of Commodore 64, but obviously I am using modern computers and modern programming languages, and I try to use those modern programming techniques when I teach programming Commodore 64. So I use modern tools like the kick assembler, like the C64 debugger, and I teach modern programming techniques like test-driven development, which is possible and quite fun on Commodore 64. Those lessons are useful for games. You can learn how to design sprites in the sprite pad. You can learn how to handle the joystick. You can learn how to split the screen, so you can create your own Kickstart 2 or a Kickstart game. It's useful for demos. So if you want to write your first demo, you can find some useful techniques that will allow you to create some cool effects for your first demo. And if you are interested in one episode, it's just 5 to 10 minute video, one small epiphany. You also get a full transcript, so you don't need to slow down and pause video when you watch it for another time. You just need to read the transcript, and you get the source code that is divided in steps, so you can follow along even from the middle of the lesson. And it's so if you want to get deeper, you can follow along. If that small epiphany is not enough for you, and if that's not enough for you, you can also make exercises. And every episode on 64 bytes is less than $4. If you are interested in one specific technique, just grab one episode and you're good to go. If you want more, I have something called seasons, which are just bundles of 9 episodes, and there are 12 of them. If you want more than a couple of episodes, just grab a bundle and you will get 9 videos, 9 small epiphanies, source code, and everything there, but for the lower price, because one season, 9 episodes costs less than $20. But wait, this beauty turns 40 this year, right? So I planned something cool to celebrate. All prices will be reduced, but next week, not right now. Next Monday, all prices will be reduced to 64%. So next Monday, you will be able to grab one episode for $2.55 or 9 episodes for $12.79. So if you want to grab one episode or a couple of seasons, wait. So if you want to try it out, want to buy just one episode or just season or two, wait 1 week. It will be less expensive. But you can also get all of them. Because 64 bytes is a huge library of short video lessons, and there are 108 released episodes. This is 108 videos, 108 epiphanies, 235 exercises, 156,000 lines of code, and you can get all of this in one package, which gives you the best price. You can get everything with one package, with one invoice, and you can get it for $1.99. But because you were so patient, I have a special deal for you. So even at this price is less than $2 per episode, but today I have a better deal, and it's a secret. It won't be published. It will be known only for everyone who watches this video or is live. You can get everything for just $1.19, which is just $1 per episode, and this is the best deal there ever will be. So if you want to get all of them, grab this package. If you want to grab just one episode or a couple of seasons, wait 1 week. So if you go to this URL, I will type it in the comments. It's 64bytes.com/all. Oh, sorry, I made a typo. Hopefully. Yes, sorry, I made a typo. Once again, 64bytes.com/all. And you can start programming today. You don't need Commodore 64. You just need any computer, Windows, PC, or Mac. You just need an emulator. You just need a kick assembler, an editor. All of those things are free. And you can start playing around with Commodore 64 and learning how to do those things in a most efficient way possible. Brian just checked, I only have 106 episodes. You should have 107. The last one will be released today, and everybody who gets this season 12 or the whole package will get a new episode soon. Can we pre-order the next 10 seasons? Not yet, because I'm not sure I will be doing the next 10 seasons. I'm thinking about something a bit different. But when it will be ready, I will let you know, and you will probably be able to pre-order it. Yes, so I'm glad that this question has been answered. Damn, I already have them all. I have a great idea for you. If you have a friend that could be interested in programming Commodore 64, I think this friend will be happy receiving a gift from you. A bargain, I agree. Some videos use older kick-ass syntax. Yes, that's true, and those videos will be updated. Don't act now. Wait a week. Only if you don't want to get everything today. Like today, this deal will end on Friday at 9 p.m. my time. So you have about 4 days to decide if you want to grab them all. If not, you can wait a week and then grab any episodes or seasons you want. If you want to grab them all next week, it will be more expensive. So this deal is the best deal if you decided to get serious about programming Commodore 64. All right. So if you have any questions about 64 bytes or the presentation, I will gladly answer them. I'm just looking for questions. Tobias, sorry, Tobias, I have no friends. Well, if that's true, that's a great excuse to get more friends. Just buy people 64 bytes and they will be your friends for life. Any other excuses? Not the spectrum. That's not the question. Let me know what did you mean about that? Okay, 64%. What an odd number. Well, Commodore 64. What do you need? It's a pretty nice round number. What do you want? Yes. So one thing that you will find if you watch the first episode, in the first episode, I tell you how to install tools. This video is kind of outdated, especially on Windows. So I will record a new version of that video, hopefully soon. And I will also record a version of the video for Visual Studio Code, because at that time when I recorded it, Sublime was the best editor that you could program Commodore 64 with. But right now, the Visual Studio Code with a plugin for programming with Kick Assembler is a bit better in my opinion. So, and more importantly, it's easier to set up. We want more. Okay, I'm doing my best. I will try to do better in the future and release new episodes and new lessons. And yes. but that's for the future. I will let you know for sure. So the environment setup, if you go to 64bytes.com and you go to seasons, not to seasons, but to episodes, you will find the first episode for free, which will tell you how to set up the Sublime. Try to do it. If you have any problems, let me know, and I'll try to help you. Yes, the transcript is in the Markdown. You can create a PDF out of it. Yeah, that's a good idea. You can even print it. Someday in the future, those files will be nicely formatted. I use Markdown because it works everywhere. It's just plain text file, and it works just fine. If you can open the source code, you can open the Markdown, so it works on every platform. Thank you. Can we expect new lessons in near future covering more complex stuff such as multiplexing, VSP, AGSP, and so on? Yes. Yes, I started looking into multiplexing, and it's quite complicated. It will probably be released in a different way, not in the form of 64 bytes short lessons, because it's to cover multiplexing, we need to learn how to sort, how to time it, and how to design the movement of sprites so that it doesn't blink, and talk about different ways it can go wrong. So it's kind of a complicated topic that will need to be split into separate lessons, and it will probably be a separate bundle that will tell you how to do a multiplexer from scratch, but it probably will be separate from the 64 bytes, those separate lessons. But we'll see about that in the near future. When it comes to VSP, AJSP, so if I remember correctly, those are the effects that allow you to not only, but also scroll the screen faster than the hardware scrolling. Basically, to tell the VIC2 chip to map different parts of the memory really quickly. I don't remember details. I didn't research those subjects yet, so I'm not ready to record lessons, but yes, I do plan to cover more complex stuff. I need to understand moving sprites around the screen automatically. Struggle with that. So I have good news for you. I have a lesson about that. Couldn't you have more than 8 sprites on a line with multiplexing and care for mid-raster line timing? No. On one specific line, you can only display 8 sprites. And one important thing is that once the VIC2 chip starts displaying sprites, it will not stop until the whole sprite is displayed. So if you try to move the sprite in the meantime, or change some configuration on the sprite, you will get some unexpected results unless you know what you are doing. There is a way to make the sprites shorter, but it's really complicated, and I can give you a link for that, but it's more complicated than sprite multiplexing, and it's hard to do that in practice. Does the current code from your videos run correctly with KickAssembler 5? Most of them, yes. There is one lesson where I covered one hack for encoding PETSCII characters, and this hack stopped working. But then KickAssembler included a feature for character encoding, so there is one lesson that is definitely outdated, but most of, like, all of them should work fine. It also changed the syntax for macros and pseudo commands, but I think the old syntax should work fine still. Did you ever follow 8-bit show and tell on YouTube? I don't remember. I follow plenty of people doing stuff on Commodore 64. I don't remember the name of that particular channel. If you tell me what it does, I will tell you for sure. Do you know if people are using AI to come up with new Commodore 64 algorithms and solutions? I don't know about that. It might be possible some way. Probably more like creating a genetic algorithm that will try to create a working program that will do something on Commodore 64, because you can create multiple programs, you can mutate them. You can create a machine code, which is just a stream of bytes. Then you can create another one, you can mutate them and just swap those bytes, and add some additional changes. So basically, this is a random process. And if you generate like 100,000 such programs, you try to run them, discard those that don't compile, try to run those that run. Take a screenshot, take a look at the screenshots. If the screenshot is close to the effect that you wanted to achieve, you let this program leave to another generation, and you generate another generation, and you do that thousands of times, and maybe then you will generate an algorithm that will do something for Commodore 64. That's interesting. I'm not sure if anybody did that, but that's definitely possible. I wouldn't be so... I don't know how would somebody use, for example, neural networks to do stuff for Commodore 64, maybe to tweak some parameters, but yeah. All in all, it would result in generating the code for Commodore 64, which would have nothing to do with AI. But yeah, that's an interesting thing that could be possible. I know that somebody created a Bitcoin miner on Commodore 64, but I don't think he mined any Bitcoins with that processing power. Oh, great. So Tony will post a link to his sideborder Sprite scroller when this gets to the end. Commented source code included. That's great. I will love to read that. Yeah, at that point you're using all the CPU measuring the screen. Okay. So that's an answer for the question. Yes, that's true. I will add to that there are other techniques to get the stable raster. You don't need double interrupts, but this is probably the easiest to understand method. So that's what I covered in 64 bytes lessons. Okay. I'd love more. A follow-up on making raster bars like in demos would be appreciated. So what you need to do to make the raster bars more exciting is to make the raster line that is scheduled for executing the bar dynamic. So instead of calling the interrupt at the same line every time, you just create a table of values for specific raster lines that can be animated. You can generate them with a sine function. So it will be like 251, 251, 252, 253, 255. And if you basically you increment the index of the table, you read the value, you put it into the register, so you schedule new interrupt at the different line, and then your raster on each frame, your raster interrupt is executed in different line, so it moves on the screen. And this way you can make dynamic raster bars that move up and down, for example. Okay. A download all button would be nice. I agree. I host my videos on the service called Gumroad. That's because I'm a one-person company. If I would need to create a hosting platform for that, I would probably have even less time for creating Commodore 64 stuff. So I use Gumroad. It's not as user-friendly as it could be. I would love to create my own platform for that. Maybe it will happen this year, we'll see. But for now, the easiest way to get all episodes is probably to connect your Dropbox account with Gumroad and get them all to your Dropbox account. And that's it. Have you ever thought about writing a C64 game? Yes, all my life. Basically, I started doing 64 bytes just to learn assembly to create a game and a demo someday. I have yet to do that, but yes, that's on my bucket list, and I think I'm closer to that than I was before. And for sure, when I will make my first like real game for Commodore 64, I will definitely create a course on creating games for Commodore 64. So that's also on the agenda. Oh, yes, this is interesting. This is about the question for AI generating code for Commodore 64. I forgot about that. It could use a generative model like GPT-3, and this is reality. If you code in Visual Studio Code and you install the GitHub plugin Copilot, you have a GPT-3 code generator in your editor, and it can actually write an assembly code. Not everything makes sense because it didn't have that many of assembly lines to learn from, but it's surprisingly good. So you can already do that. Is it hard to make a game using RU, especially for emulator crowd? I'm not sure. RU is an extension. This is the additional memory for Commodore 64, right? Or is it the CPU accelerator? Or is it both? I don't remember. If it is additional memory, so one exciting thing that this allows you to do on Commodore 64 is to stream de facto stream memory from this extension to the memory of Commodore 64. So you can create an interesting effects, like record a video in that part of the screen and then stream and the stream bitmaps from this RU to Commodore 64, and it looks amazing. I'm not sure how hard is it to make a game using that. When you know how to make a game on Commodore 64, so you know the game loop and the basic stuff, how to get the input, how to put stuff on the screen, how to do double buffering, how to do plenty of other stuff and also play music, then you need to think about which specific feature you need for RU. Well, what do you need RU for, and then use it if you really need to use it. For emulator crowd, I'm not sure. I think RU emulation works most of the time. I'm not sure how good is it, but I've seen a couple of demos in the emulator. So the important stuff should be working. When it comes for on a real Commodore 64, you don't need an actual RU if you have Ultimate 64 or the Ultimate cartridge. You can emulate the RU in that, so that should help. Are there secret cracking lessons? No, not really. Yeah, cracking was something I was interested when I was smaller. So when I was 15 years old, I wanted to understand how to crack games and demos. Right now, it's not as exciting, and it also discourages people from creating games for Commodore 64, I think. So it was cool a long time ago when it was hard to get games in Poland, for example. But right now, well, it's good as a hobby, but if you crack games and release them, especially those that are commercially available, well, that's piracy, and it's not really cool thing to do. But like, it might be interesting. If you have concrete things in mind, let me know, and I might research the subject and write a lesson about that. Oh, if you update videos, how will we be notified that there is new video? Whenever I update a video on the Gumroad service that I use to host my videos, I have an option to notify everyone who bought this episode or bought this season or bought the whole package that something changed. And then I click a checkbox and you will get an email with changed files. Yes, if you purchase all of the episodes, then future updates for those episodes will be free. Right now, there is one episode that is not yet released, the 108. The script is already done. The source code is already done. I need to just record it and then I will publish it. If you buy it now, the whole package, the 12th season, you will get this episode for free. And if I update any lesson from those seasons, obviously everyone who bought it will get it for free. Every new episode and every new course will be offered separately. A long time ago, I offered subscription. If people are interested in that, and I might go back to it. But for now, you can buy separate episodes all seasons or the whole bundle. And if something new shows up, I will let you know. Color cycling. Oh yeah, that's another interesting idea to make, for example, raster bars more interesting. Um, well, you can have an array of colors and then copy those values into the border color or the background color, and you have dynamic raster bars that change colors. You can take a look at one of the early lessons on 64 bytes when I show how to animate sprites and animate colors, and it will be really similar to that. Oh yeah, RU is RAM expansion unit, so not the CPU accelerator. Maybe a copy protection topic instead. Yeah, that's also might be interesting. I'm not sure how how many of you would find it interesting. What I find interesting though, and what I will definitely would like to record a lesson about, is tape loader. Because I don't know, if you own Commodore 64 and you loaded things from disks, it usually took it was not that long. Like it didn't take that much time to load the game from a disk. But if you loaded it from the cassette tape, then it would take half an hour, and you needed to stop a briefing during that time, because then you will get errors. But one of the interesting things was that some companies created custom loaders that displayed graphics and displayed music, and I always wanted to know how it's being done. I know the gist of it. The idea is that you load the program sequentially, and at some point in time you override the program that loads the program, and then you can execute some code and, for example, display some graphics and play some music while you're loading the code. I think it's interesting. I will gladly take a look into that. Copy protection, yeah, it's also interesting, but right now copy protection on Commodore 64 is more useless than it used to be back in the day. But it might be interesting to take a look at different ideas people have had then. Oh, this is interesting. The idea of truly random numbers generated from SID chip noise. Yeah, so SID chip, this is the chip that generates music. It also can generate white noise, and it has a register that you can read those values from this hardware chip, and those values are not very bad random numbers. Let's say it like that. And they are close to truly random, so that's cool. Oh, one more thing. So for all of those who wanted to stay till the end, I can tell you a secret code. It doesn't work yet, but yeah, let's figure it out. What can it be? Oh, I know. This will be hard for you. This will be tough. So the secret code is Atari. So this code will be, I will enable this coupon code today. It will be valid tomorrow. So if you go to 64 bytes, you go to season 1, and you try to buy it with the coupon code Atari, in 1 hour it will be free for you. And it will be free for 1 day. So if you don't manage to do it today, in the next 24 hours, you will be able to grab it. So that's it. The secret code is Atari. I won't write it anywhere. You need to remember it. Atari. Okay. Any other questions? Have you heard of quaint copy protection where data was hidden in images? You mean in Commodore 64 or in general? I didn't know about this method on Commodore 64, but in general, I know about hiding secret messages in images. Which Commodore 64 color is your favorite? Brown, of course. What do you mean in SD? Will your season 1 be in HD? So I recorded all those episodes in the maximum possible resolution of my screen at that time. So I don't think, if I don't update those videos, they will stay the same. But if I will update them, I will try to record them in better resolution. But for reading text, which is the only thing that you do in programming lessons, you don't need high definition for that. 720p is more than enough, and those episodes should be in high resolution. Oh, one more thing. If you're watching them on Gumroad, they might be streaming in low resolution, but if you download them, they should be pretty crisp. Oh, the season 1 was in low quality. So Hamraf is talking about the bonus that was added to the Kickstarter of this book a long time ago. So that is weird. If it was in low quality and you have this season, you should also have it in Gumroad. If you don't have it, just drop me a line and I will give you. Well, you can use the Atari coupon code and you can grab it and see if it's the same quality. Yes, this is the quality for 40 times 25. Can we write suggestions on future episodes? Yes, definitely. Just drop me an email, and in the future, I will have a better system for getting a feedback like that. You little joker. Well, it's by design. Some people hate Atari so much they will pay the full price for the first episode. You don't need to use it if you hate the word Atari. Do you plan to use 64 specs so it works with KCAS 5? Yes, I plan to update it. Not sure when, but definitely someday. Just to be clear, I don't hate on Atari, and I don't plan on hating on Atari. I only do that jokingly with my Atari friends. But there is an interesting thing when it comes to coding Atari. Most things that are hard on Commodore 64 are easy on Atari. For example, there is a command that you issue to the graphical chip to synchronize the raster interrupt. And on Commodore 64, we need to do that by hand, like animals. But this is also what makes programming Commodore 64 interesting, I think, at least for some people. Oh yeah, this is interesting. 80-column text in Commodore 64 could be an interesting topic. So if you have an idea for an episode, just drop me a line at michal@64bytes.com. I will put it into the spreadsheet. I will count how many people want to learn about different things, and those topics will get priority. For now, my plan is to release the last episode, get it over with because it's long overdue, and then work on some other exciting topics. Probably, most likely, more advanced than whatever I've done before. Yes, unfortunately, some things are harder on Commodore 64, but thanks to that, we have this exciting stuff happening. So one interesting fact for those of you who stayed with me until this time, do you want to know the secret behind speech synthesis on Commodore 64? How to make your computer play any sound or sample sounds or speak? And I don't mean the most state-of-the-art method that is really sophisticated, but the easiest possible solution. How to do that? Any ideas? Yes, this is the right answer. So when it comes to speech algorithms, so this is like a really wide topic. Basically, you need to create some basic sounds, basic phonemes that are that you can then combine to generate words or other sounds. So you basically first create a bank of building blocks that you will combine and then create music. But that's additional topic. I'm only talking about making Commodore 64 run play any sound, because Commodore 64 has a SID chip that can generate some music, and this music sounds like a chiptune, like a pretty sophisticated chiptune, but it's still chiptune. It has sound wave generators and can play some specific kinds of music if you are skillful enough. But it's possible to sample music on Commodore 64, and you use volume register glitch to do that. There is a bug on Commodore 64, and this bug became a feature. The bug is simple. Whenever you change the volume registers, you want to make the subchit louder or more silent, there is like a tick, like a glitch that makes a ticking sound whenever you touch the register. So you change the volume, the tick gets the tick is louder or not even louder. It has a different frequency, I think, that is correlated to the volume of the sound. So if you change the volume fast enough, you can generate a waveform of these clicking sounds. And you can play a pretty sophisticated stuff using this glitch. So this is interesting as a topic because it's a bug that has been built into Commodore 64, and people used it as a feature, and then this bug was fixed in a couple of Commodore 64s, and then people took their computers and took a solder, took some kind of hardware and introduced the bug again, just to make the glitch work, so that they could have the speech synthesis or sampling on Commodore 64. So, and there is plenty of other examples of things like that, like opening the border is using a glitch related to how the VIC chip generates graphics on the screen. The mentioned VSPs, AGSPs, and some other tricks that can be used to move stuff around on screen also use some weird quirks of Commodore hardware. So there are no bugs on Commodore 64, and everything can be used to do something cool, and that's what's exciting for me on Commodore. So this is not the only way to do speech synthesis and sampling on Commodore 64, and right now like the state of the art is something else. I don't know the details, but there are better methods than this already. All right. I don't see any other questions. If you have something that you wanted to ask and I missed your question because there were plenty of them, feel free to drop me a line at michał@64bytes.com, and I will gladly answer, and I will gladly help you. And that's it. Thank you for being here live. And if you're watching a replay, thank you for watching the replay. Let's keep Commodore 64 alive. Grab a couple of episodes. You can grab a couple of free episodes. You can buy some episodes. Whatever you do, create something cool for Commodore 64, and let's not make our beloved computer die. Long live Commodore 64, more 40 years for him. All right, thank you for being here, and see you soon.